Rational equations contain one or more rational expressions, often with a variable in a denominator. To solve a rational equation, we need to list any restrictions that exist. In other words, numbers that make a denominator equal to 0 can never be solutions. Well, in this first equation, we don't have variables in the denominator, so we don't need to concern ourselves with that restriction. The next step to solve this equation then is to clear the equation of fractions by multiplying by the least common multiple of the denominators. That least common multiple is going to be 2 times 3 or 6. Maintaining equality, we'll multiply both sides of the equation by 6. Distributing the 6, here on the left, we end up with 6 times x over 2 plus 6 times 1/3 is equal to, we can simplify this one, 30 over 2, which reduces to a 15. 6 on the left has a denominator of 1. 6x over 2, or canceling out that common factor of 2, leaves 3x for the first term. 6 over 3 results in 2 from the second term. Solving then, we will subtract 2 from each side. 3x is equal to 13, and to solve for the variable, undo multiplication with division, which gives us a 13/3. We would want to check this solution in the original equation to verify that we have solved it correctly. Here we have another rational equation with a variable in the denominator, so we do need to determine any restrictions that exist. We do not want numbers for y that make this denominator equal to 0, so we are avoiding this happening. We do not want y minus 3 to equal 0, and if we add 3 to both sides, we end up with y is equal to 3. Because this is on the restriction list for values of y, I'm going to write it as y cannot be 3. We have to keep that in mind then when we get our solution to make sure a solution is not that value, which we would have to reject. Then we're on to the same step or procedure that we used with the previous problem. We're going to clear these fractions by multiplying by the least common multiple of the denominators. Since there's only one denominator, we will multiply both sides by y minus 3. Multiplying both sides maintains equality. On the left, we do have a distributive property to clear those parentheses. So y minus 3 times the first term, our rational expression, minus y minus 3 times 1, which is y minus 3. On the right-hand side, the y minus 3 has a denominator of 1. We have a common factor of y minus 3 over itself, which results in a 1. On the left, taking care of our multiplication, our denominator is canceled out, as was the goal, leaving 1 times 4 or 4. We're subtracting a quantity. We have a minus 3 minus a negative 3 using the rule for subtraction or definition of subtraction. We can turn this into addition by changing the signs to the opposite. So we end up with a minus y and a plus 3 is equal to 1. Solving then, on the left-hand side, we will combine like terms. 3 and 4, our constant terms are 7. Subtracting 7 from each side leaves us with negative y is equal to negative 6. Multiplying both sides or dividing both sides by a negative 1 gives us a solution of 6. 6 is not on our restricted list, so we can accept it. The only other thing left to do would be to check to make sure that we do get a true result when replacing y with 6.